Welcome to another episode of the Cool Tools Show and Tell. Our special guest this week is Daniel Kim. Hey, Dan, would you like to introduce yourself to our audience?
Yeah, my name's Daniel Kim. I am an inventor, I'm also the CEO of a company here in San Francisco and Portland, Oregon. And I like making things. I think that's my best billable hours, is making and inventing things. So I'm very hands-on, and I like to think about systemic, globally impactful inventions that are helpful. So that's the
And right now, you are broadcasting from a shop. In your background, for those who can't see, is a shop with various things in different stages of completion. And I know that given your own interest as a maker, that you have some really cool tools that you work with. So, Daniel, tell me about one of your favorite tools, a tool that you really like.
yeah, I think one of my favorite tools is actually one of the foundations of the Industrial Revolution, at least in the United States. It's called the lead screw. And
Can you describe that for us?
yeah,
What does it look like?
I think it started off as a piece of wood, or maybe it's usually a metal bar as we know it today. And it's basically just a spiral that has a really deep groove, square groove usually. Um,
When we say
that
square groove,
I
uh,
mean, not being square and groovy at the same time, but that's a contradiction. But it's a groove, kind of like a thread, but it's usually square. The groove is actually square
oh,
in
I
its
see.
depth.
Instead of the cross section being kind of like a point, like a triangle, it's
Hmm.
lopped off at the top so that there's a flat surface, so to speak.
Yeah, and there's a flat surface in the valley, in the bottom of the
Right,
valley
right, right.
of its cross section. So
And so what's the advantage of a lead screw versus like a threaded rod?
well, a threaded rod isn't as robust. The lead screw was the foundation of machining, and also one was introduced to, I believe, Slater Mills in Rhode Island, which is I visited a museum there, and I guess that was the birthplace of the tool shop, or the tool room, tooling, and which was the birthplace of part of the Industrial Revolution, at least to my knowledge. So, yeah, basically it's a long cylinder, and there's a big square groove, that spiral cut. I think that was made with a file
Okay.
a long time ago,
So what's it,
and
so for a maker, so someone in your
hmm
shop, if they're making something
hmm
and they have only a threaded rod on hand, should they go out and get a lead screw instead? And where would you get it? And when you're getting one, what do you want to look out for?
Well, I just feel like it's my maker's baby blanket for if I ever have to, rebuild society. It's a little bit like the zombie apocalypse, but from an industrialized tooling standpoint, where you have to maintain some of the basic the industry of, like, of a loom, of maintaining
Uh-huh.
looms, or the cotton gin,
And
or
you can't do
whatever.
that with a threaded rod.
I would just take a bar of mild steel, hot rolled, and get a handy file. And it's more of like a kind of meditative um, uh, kind of exercise or approach to making. And I would try to make your own lead screw, um, with basically a Sharpie or a
Right,
pencil.
right.
Just create a spiral, and that will create a groove that if you spin it, like off of a water wheel with a leather belt or whatever what they use at Slater Mills. You can basically relive the birth of the Industrial Revolution.
Okay.
And with
So
that,
we're kind of interested not in making our own tools, but if someone wanted to get a lead screw, where would they get one from?
you could get one at on McMaster Car,
Okay.
definitely. All thread technically is kind of a lead screw. As I said, it's more of an emotional tool
Okay.
for a maker, at least for me. That's kind
Okay.
of how I think about tooling.
And
It's
where have you put a lead screw recently? What's your
I
last time you used it? What did you use it for?
I used it as a hammer actually because it was really heavy, but I broke this vise over here, and I had to replace the lead screw, which allowed me to clamp. Um,
Okay.
and that was something that it's used everywhere. There's a CNC mill over here that uses that lead screw. So
Uh,
as I said, it's more of an emotional tool.
okay.
That's kind of how I think of it. I think one of the key tenets of being a maker is having emotional fortitude and resilience,
So
because making is
when you're
hard.
feeling down or depressed, you make something with a lead screw.
Yeah, I think it gives me confidence that I can make anything.
Okay.
Uh, yeah,
All
so I
right.
guess you could say the handy file is part of that as
When
well. But
when you're shopping for a lead screw, is there anything that you want to keep in mind or that you want to avoid?
hardness, you want to make sure it's a hard. It has a Rockwell over, you know, at least 40. So
So, and how do you tell that? Is that just from what it's specified, or is there some way to tell the hardness
Uh,
of your screw?
yeah, you can tell if you get a file, or if you use steel or you have something aluminum, you can tell the hardness by how hard which metal deforms faster or more significantly.
Okay.
And that will tell you, aluminum's got a pretty low Rockwell. I think that's uh, somewhere around like it's like wood, basically like
Okay.
20 or something like that. So
All right. So the threaded screw for emotional support. So what's another tool, a favorite tool of yours that you think most people might not know about?
Um, uh, I mean, might not know, but I really love my grown up paper and scissors. Um,
I think
what
everybody knows about paper and scissors. What's something that people
or
wouldn't
or
know about?
glue or glue and scissors, which is a sorry, is my plasma cutter and
Oh, your plasma cutter.
yeah,
So tell me about the plasma cutter. Is there a particular one that you would recommend people starting out with?
I would go over a half inch plasma
Is there a
cutter.
brand or a model or
Yeah, I like my Miller. I think all my tools are Miller.
okay,
Here's one of my. This is my Spectrum. I think 375 or something. Yeah,
okay.
Spectrum 375. I've had this for I don't know 20 plus years.
It looks like a welding rig.
It's right next to my welders. But this is my scissors. It's a half-inch lightsaber that comes out of the tip um, of here. I don't know
Okay,
if you can
so
see that.
what he's describing is there's sort of a case, maybe like a luggage, about the size of a luggage on a little cart, and then there's some very heavy black
Cables.
cable cords, and then you were holding a little handle that had a little pointy nib on the end, about about 12 inches, and that's the cutting end of it. That's the business end.
Yeah, this is the business end here, and then you have
There's a little red
your
trigger on it.
yeah negative connector as well here.
There's kind
That
of a
can
clothespin like clasp that would that you would use in electronic welding to ground it. So it resembles a little bit like kind of welding, but I guess the spark is continuous. Is that how it works?
Yeah, it creates an arc and it blows uh, air, and the air gets ionized, and it creates plasma at like 2,000 degrees, and it will, based on the airflow and the amperage and the voltage, obviously, it will create like a little lightsaber, basically.
Okay.
So,
And
so
and and how thick of steel could you cut with that?
I can cut around half inch very slowly with this one.
Okay.
Um, pretty easily quarter inch. And so that's kind of how I think about my scissors, is that's my
Oh, I see. Okay. And
small
and and
lightsaber.
and and how much would that unit cost?
A unit of these cost anywhere from a couple $100 to um, thousands of dollars. It depends on the duty cycle.
But the one that you're showing us, the Miller,
That I think that one probably now is like just maybe $300-400.
three
You
or four
could
hundred.
probably get them at Harbor Freight or at your local Miller dealer.
Okay,
So
so for $300 or $400, you can have the thing that will like in the movies, you just cut through the safe. You just cut right through it.
yeah, yeah, I guess so. Yeah, if you had 220 power, or if you had a portable unit, I'm not sure if they make portable units for just that reason.
Right. So
But
so you need 220 voltage. Do you need any gas like you do in welding?
no, you just need air supply, compressed air.
Okay, just
So
compressed air. Okay. And is there some advantages to the plasma cutter to the other thing that you used to use in the old days, like oxyacetylene torch?
torches.
So
Yeah, I mean,
what's the pros and cons?
the oxyacetylene torch has it's less localized of a cutting of your incision. It's a lot. This plasma cutter can cut with basically an eighth of an inch of a actual cut width. Your depth could be up to half an inch depending on your tip and your how
Uh-huh.
steady your hand is. The heat distribution of this plasma cutter is very, very small, maybe a quarter inch, before you get any deformation in your material, or you can like minimize the annealing properties of the process.
Right. So it
Um,
sounds like it's superior to an oxyacetylene torch then.
I would say superior in some ways. If you're going to break into a safe, I guess I would take the oxyacetylene uh, torch instead. Definitely more mobile. I don't know if you're worried about the safes. If the steel in the safe is normalized or not.
So you would
Post.
rather move those big tanks of gas than that little um cart.
Or you could have small tanks of gas
I
and
see.
just use it for a quick grab and go.
Okay.
Um, I don't rob banks or break open safes often. You know,
So
but
the
maybe you can impart your wisdom on me. So.
and so the cut you would use something like this to cut steel, I guess because you might have an irregular cut versus I'm not sure how else can you cut half inch steel or or even quarter inch. Is there any other? I mean, I guess you might have a bandsaw that might cut it.
Yeah, you could use a bandsaw. I have one of those back there, but
Yeah.
you can make a lot of irregular shapes and cut with the plasma torch. There's a CNC option for it as well.
Okay.
But usually just straight, deep, thick cuts. If you want to do, you could use an iron worker for that. I have one
What,
of those over
what's an
here.
iron? What's an iron worker?
An iron worker is just basically a very large hydraulic cylinder that in this case, it creates a punch, and then there's a shear, there's bender, sheet bender, plate bender, and there's a bunch of other shears. And that's one good way to work with metal.
Okay,
Very, very,
you were showing us a very large
a very
cabinet
large
size um,
machine. Yes,
machine that had can't really see what it does because it has a very nice enclosure. But it's imposing. It looks heavy.
it's heavy. It's definitely heavy. Yeah, I don't
Yeah.
remember how many thousands of pounds it is, but it's definitely bent the floor at one point. We
Yeah.
had to move it.
And
So
on the front of it, it says 65 ton, which is not its weight, but I'm sure it's force.
yes, it's force, and it's a an inch and a half, two plates of inch and a half steel um, that basically create the frame for a large hydraulic press and cutter and the ram
Yeah.
and it does five different functions at once, and you can
Okay.
pick which function
All right. And that's
you
called
want
an
to cover.
iron worker. That's a cool tool.
Yeah, yeah,
Edwards.
it's a cool tool.
So Daniel, what about a third tool that you use and like, and maybe most people don't know about?
Well, if you're gonna have scissors, you at least for me, you have to have glue. And so a lot of people, I like to work in a lot of materials. Metal is, is one of my favorite materials. I love MIG welders, specifically a pulsing MIG welder.
So,
Um,
people might know about welders. They may
mhm.
not know about a MIG welder, and they probably don't know about a pulsing MIG welder. So maybe you can just walk us through those differences. So,
Yeah. Yeah, no, absolutely. There's a normalized MIG welder, which
what's
which
a
is
regular welder before we get to MIG welder? So, a regular welder would be,
a
um,
gas welder.
yeah,
A little bit like a acetylene torch, and you just get
okay,
the two metals at the right temperature,
okay,
1800 degrees, 1500 degrees, add some kind of filler rod. That's one, gas welding. And then there's TIG welding, which is the same basic process, but it's a smaller, more localized um, point of basically using a filler rod and melting the metal with a filler rod to do the same basic process, but it's a lot more targeted and localized heat distribution. It's very artisanal as well. And then there's MIG welding, which is more for higher production, welding. That is a little bit messy. I think it's not as, it's a lot faster, but it's more messy. Sparks are going everywhere. And the process really, you can't really dictate the heat temperature control of and the deformation of the materials that you work with. So pulsing MIG is interesting because it pulses. It's where MIG welding and the sound sounds like uh, a pulsing MIG sounds like, so it's a lower frequency and it
okay,
turns off and on.
okay,
Uh, and the sound that it makes is it basically turns the voltage or the amperage on and off really quickly, and it creates a low hertz uh, uh, spark, and that spark kind of regulates the temperature of that you're introducing onto your material with the filler rod, and it's just a lot more visceral. It's a better process for
okay.
welding as well.
So,
Um,
I know that you can buy fairly cheap MIG welders. Like, is this the kind that has like the wire feed?
Actually, yeah, that's a spool gun. You can MIG weld with a pulsing MIG with a spool gun. That's usually used for aluminum, which I can do on this on my pulsing MIG of choice. A better way if you're going to do that is to actually use a push pull gooseneck MIG welder, and the gun for that is, it's an add-on. It's a little bit more expensive. You can get them cheaper for like $800, I believe.
You can get wait, so
Harbor Freight.
you can get a Pulse MIG for $800, but it's not a spool fed. Is it like using a stick or what?
No, this one, I mean, I've been dreaming about this, welder. It's a bit bigger than it's about the same normal size as the normal MIG welder. But the difference is,
You're holding up a
the
very large, it's like a bat or I don't know what size that
it's
would
a
be.
it's a bigger gun,
Right.
yeah, MIG welding gun, and this, if I open it up, and you usually can't, like, compared to a spool gun, you usually can't open those up, but inside the internals there are two pulleys or gears, running gears that pull the wire, your
Yeah.
feed wire, into from the machine. It actually pushes and pulls
Right.
the wire from the machine, and then it pushes from the machine and it pulls from this gooseneck
Okay.
and gun, and it will create a really great feed rate that's really consistent, which is important for a pulsing MIG, because the actual arc and where the metal melts, it's actually a little bit above the material. It's
Right.
very, very, very it's a very calculated, very controlled, gluing process,
Right.
as I would.
If you were a rank beginner and you had the money, would a pulsed MIG be a better choice for you than just a regular MIG?
Um, it depends if you want to work with like metals, like 4,000, 5,000, or even 6,000 series metals, like aluminum. I would say that's a pulsing MIG is a great choice. Let's just say if
Uh-huh.
you make your own aluminum boat, if you had the money and were kind of a beginner,
Yeah.
pulsing MIG would definitely be a way better choice.
What if you're just using
Useful.
steel, not aluminum?
You can do steel too. Steel is also very good if you're using thinner steel or really expensive, like temperamental steel, and you want to do it fast and with less heat.
Right.
It's almost similar to TIG welding, in how much heat it introduces into the material,
Okay.
but it's a lot faster. And in some cases where you're working with a tempered material, or you have to deal with the cooling cycles and you have to retemper it later. Sometimes it's better to work with a pulsing MIG.
Okay.
It depends.
So,
But I would say it's an amazing
and so
tool.
would you recommend the one you have, the Miller pulsing MIG? Would that be something you'd recommend?
Yeah, I like Miller tools. I like Miller. Lincoln's also nice too. But I've had Miller all my life. I've had all these welders and plasma cutters. Some of them for over 20 years. So they're kind of friends of mine, I guess, is
Uh-huh.
one way to put it.
But so
So
you would recommend them.
yes, yeah, absolutely, yeah.
Okay. So Daniel, what about a fourth tool that
Yeah.
you maybe use on a regular basis and people don't know about, or you would hate to lose and or be one of the first tools that you might replace if you lost your shop? What can you give us a fourth tool?
Yeah, I would say, you know, uh, I like to prototype a lot, and before I go into metal, I usually use paper or cardboard. So I use all. This is kind of you wouldn't believe, how useful foam core or cardboard or, even paper is, to simulate, going into steel. I built a car, a Land Rover, over a long time. But I built one recently, 80% from scratch. I don't recommend it, and it works, but um, I really went straight from paper or cardboard and did all the architecture of that. It just went straight into steel, and you can use this really beautiful, amazing material to do quite a bit to simulate not just structure and shape, but also you can also theorize load paths, from an engineering perspective. And the failure you can see in paper, like if I was to mold this into a chair.
You're holding up a piece of paper, just like an 8 by 10.
Yeah, so
Yeah,
I'm just kind of like folding it.
deforming it.
And I think Frank Gehry used to do this to build tables, but you can shape it, and I'm making like a little like cozy chair here, and it doesn't look like one, but so it's folded around. Here's a little seat, and then you can pull it apart, and you can see where all the failure is. And in this, you can see here's the seat back, here's the creases for the
Uh-huh.
sides, and you can average these. And then there's, here's a leg, here's a leg, this is a leg, and
Right.
then you can say, oh, well, I need some more structure here, I need some more structure here, and then you can refold it back into its shape.
Okay.
And so I'm folding this and then make something a little bit more structurally
Right.
rigid.
Right. Right.
It's
And
a very simple
with the
way.
foam core, you just use hot glue. Is that what you would use?
I use tape, hot glue. You can do the same
It,
thing with foam core. It's just on a larger scale,
right.
and it's going to be a little bit. It's a little harder to work with in that crumpling paper,
Right. Right.
sequential failure process. But foam core is a really good. It's pretty structural. It can hold, I don't know, maybe
Yeah.
10 pounds, and you can definitely use that to simulate. I mean, one of our chassis that we built, in this, other project of mine, we use a lot of foam core to simulate, what it would look like, and then eventually what it would kind of feel like, supported by some wood at a full scale without having to go, spend a ton of money on like foam or fiberglass and time on
Right.
like
Right.
in sheet metal. We made it in foam core, and it's a principal foundation for all of the interns that I bring into the company, or even
Yeah.
engineers.
Yeah, no, doing things at full scale in cardboard or foam core is incredibly revealing, incredibly powerful. I suggest that if you ever do any interior decorating or furniture making, make them out of cardboard, or do put your counters and make them out of big refrigerator cardboards, see them at the right scale, test it to see if it's the height that you want, all that kind of stuff. It's really great. So, and by the way, the cheapest source for foam core is at the dollar store. You can buy usually $1 for like a sheet of, by 20 by 30 or 30 by 40 for $1 at the dollar store. It's a little thin, but it works. So it's a great source for really cheap foam core. So, Daniel, that was a great one. I like prototyping tools. Fantastic. Foam core. T Tell us a little bit about your passion project and or what you're working on right now.
Yeah, my passion project is behind me. It's something I've been working on for a while. It's a self-balancing, two-wheeled, fully enclosed, gyroscopically balanced electric vehicle.
It looks like a
It's
motorcycle with a canopy
yeah, it's
that
a
has
so
right now that doesn't have a covering. It's kind of exposed. You can see the wiring and a lot of the structural components. I mean, it looks incredibly cool.
yeah, it's balanced. It's a two-wheeler. It kind of has motorcycle architecture, like a front wheel, inline, two wheels, rear wheel in the back, kind of like a motorcycle, except it has a steering wheel that tilts and leans the vehicle as you drive around. It has a seat in it like a car. You have seat belts like a car. This is just one of our last prototypes, and it's stabilized. The way it's safe is it's basically a robot, and I've built, designed most of our gyros, which are big spinning discs. This one is a 40-pound spinning disc that rotates at 6,000 RPMs, and it's housed in this aluminum casing, and it next to the rotor motor, the flywheel motor, it also has a servo or a gimbal, actuated gimbal, and there are two of them, as there are in our last prototype. As you can see, there's two here, two big ones here, and these produce about 1,000 foot-pounds of torque. And it's an incredibly robust new architecture of vehicle, which is hyper efficient. It gets 14 to maybe about 18 miles per kilowatt hour. It's electric. It's super aerodynamic. It gets like about 0.19, 0.20. It's a coefficient of drag. And, I think eventually it's going to be fully enclosed. So it shields you from the rain and the snow, and basically it kind of creates a new identity of freedom that we think we should be redefining for our future generations. And it's a company, but it's a passion of mine. And I put a lot of time with a really amazing team into this, and we're just hoping to reduce apparently a gigaton of CO2 by 2050, which is quite a long ways away from now. But
so the it's electric, so it has some of the same kind of economies that electric car, a small car would have. The gyroscopic balance, does that also balance it when it's stopped?
It's pretty magical. It's very much like a spinning. It just, when you get to a stop sign, it just stays balanced and upright, and so you don't have to put your feet down. And this vehicle, it's kind of what we expect from the same magic of technology. I think that the laptop brought us, or the PC brought us, and then eventually turned into like a smartphone. This is just doing the same thing with an electric vehicle or platform.
Right. A lot of people are sort of wary of motorcycles because they're viewed as dangerous in terms of their ability to slip or slide or whatever. Does that negate a lot of those concerns?
There's airbags. You don't have any concerns, at least from a motorcycle perspective. The balance is done for you. It has airbags, seat belts. It's a aluminum unibody chassis that we're going to try to meet, European safety NCAP homologation, and actually the gyros add a fourth level of safety, which is they will actually they will absorb impact from the side. So that was a nice surprise to discover. And so a lot of patents behind it, which is, I guess, would be a fifth tool is your brain, but can't show you that exactly.
Sure.
But it's been this is what we think is a good shot at a more sustainable, relatively sustainable future.
And when self-driving technology is a little bit more advanced, you could also see that as part of that system as well, where you summon the thing and then it can drive you, basically, right?
We haven't used AI necessarily to balance this. We use AI for the AI driver in our simulations.
Navigation,
But that simulation is very similar to if you're going to have an autonomous driving vehicle that comes and picks you up. You just have to, use your phone, use our app to, schedule a time. And it should be a lot cheaper to use as well, a lot more convenient. You should be able to, motorcycles or even Harleys will actually get to, slip through traffic and get to your destination 20% faster than a car.
Right.
So not only are we doing it, not only can you save time, but you can also save money. So, that allows you to, free to spend time with family and friends or do other things that, for your mental health or whatnot. I think it just alleviates a lot of anxiety.
Yeah. And when you get to the point of a production run, do you have an estimated price?
We're looking at, we would like to hit $16,000, per vehicle. But our first prototypes that are coming out are going to be $32,000 right now, which isn't too unaffordable. But you'd be the first kid on your block to have one.
And what's
So,
it called?
this is called the AEV. The company is called Lit Motors. It's right here somewhere.
AV, like the letter
Yeah,
A and the letter V.
yeah, AEV. It's an auto
Oh,
balancing
AV. Okay.
electric vehicle. So,
Okay.
and this is just called the C1 as a prototype. It's our prototype name, but not the
Okay.
actual name. We're still coming up with it. So if you want to go to our website at litmotors.com
Right.
or go to and send in your name, send in a name that you think would be suitable. We'd have to get your feedback.
Sure. Yeah. So this is a really cool vehicle of the future. It's not a car. It's something that's in between a car and a motorcycle and something else. And so it's really great. Thank you for showing us this preview and some of the tools that you use to create it. It's
Thank
really,
you.
really
Yeah,
cool.
no, it's been a pleasure. I've
Yeah.
always love the show. So
Well, thanks again, Daniel. We appreciate it.
thank you so much, Kevin. Appreciate it
Yeah.
too.
We are glad that you are enjoying this issue of the Cool Tools Show and Tell. I just want to remind you that we also have some other coolish material on our YouTube channel here. So please subscribe, comment, and like. This show and tell is also available in an Audible podcast form. If you just wanted to listen to us, you can subscribe to the podcast wherever you subscribe to other podcasts. And if you're already just listening to us, you should know that there is a visual version of this show on our YouTube channel where we're actually showing the tools. And there's a little bit more visual component there. In addition, the same folks that publish the Cool Tools website, that's all of us, me, Mark, and Claudia, we also put out a free newsletter every week. It's very, very short, just kind of one page or less. And we recommend 6 very brief items that are very succinct and easy to read. So you can deal with it in a couple minutes. And every week we bring you the 6 coolest things that we've uncovered and want to share. It's called Recommendo with one M. Just go to recommendo.com and you'll be able to find it there. It's free and you'll get it in your mailbox every Sunday morning. So join 80,000 other subscribers to hear what we're thinking about and what we find cool that week. It's actually one of the most popular things that we produce. We also publish other newsletters as well. One of them is a very short, free weekly, like Recommendo, but for travel. It's called Nomadico, and it gives you 4 short recommendations for people who work where they travel or they travel while working. Another one is called What's in Your Now. It features things that are significant to you right now. Could be things that you carry every day or something very near you. We have another one that's about tools and tips for your workshop, and one that extracts the best stuff out of self-improvement books. You can get all those at our website, and they are also all free. And finally, I want to mention the fact that while our newsletters are free, they're not cheap. They're handmade by humans in California, and if you want to support us, we have paid subscriptions for each newsletter on Substack. So when you sign up for a paid sub, you're making it possible for us to keep creating them free for everyone else. So thank you for being a fan of any type, and we'll keep producing stuff if you let us know that you enjoy it. So thank you.